Okay, so good day everyone. Our lesson for this day is about the whole numbers and numeration. For our mathematical task 2.2a, when a young child is asked to count the blocks in the set shown below, he will use his memorized cadence of 1, 2, 3, 4, and so on, while pointing to the blocks. In coming to understand the concept of number, the following two scenarios are possible. Child 4 counts out of the blocks correctly, point to each block once and only once, saying 1, 2, 3. And when asked to show 3 blocks, point to the third block. Yun yung pwedeng maging isang scenario. Then another scenario, child number 5 counts the blocks correctly and then when asked to show 3 blocks, indicates all these blocks. Identify which student is incorrect and explain the possible rationale behind this reasoning. Kasi yun yung dalawang scenario na pwede mangyari, di ba? Pwedeng bilangin, although parehas yung pagbilang nila using sound or yung tinatawag na memorized cadence. 1, 2, 3. So pag tinanong kung or show the 3 blocks, pwedeng yung isa ituro niya ay yung third block. While yung isa naman ang ituturo niya ay yung lahat ng mga blocks. As mentioned earlier, the study of the set of whole numbers, set of W is equals to the set of 0, 1, 2, 3, 4, and so on, is the foundation of elementary school mathematics. But what precisely do we mean by the whole number 3? A number is an idea or an abstraction that represents a quantity. The symbols that we see, write, or touch when representing numbers are called numerals. There are 3 common uses of numbers. The most common use of the whole number is to describe how the elements are in a finite set. So ito yung symbols na ginagamit natin ay numerals. Then common uses of whole numbers to describe how many elements are in the finite set. When used this manner, the number is referred to as a cardinal number. A second use is concerned with order. For example, you may be in a second line or second in a line, or your team may be fourth in the standings. So yung ganung manner na tinatawag ay pwedeng in a ordinal numbers. Finally, identification numbers are used to name such things as telephone numbers, bank account numbers, and social security numbers. Okay, so dito sa definition natin, meron tayong 3 numbers. So meron tayong 3 types on how to describe a numbers. Yung first natin ay cardinal number. That is to describe how many elements are in the finite sets. At yung isa naman ay ordinal numbers that is concerned with order. At yung isa naman ay identification numbers or naming numbers used to name such as telephone numbers, bank account numbers, and social security numbers. Numbers and numerals. What is the number 3? That's the question. What do you think of when you see the sets in the figure 2.9? Okay, dito meron tayong sets in different elements, di ba? First, there are no common elements. One is the set made of letters. One is of shapes. One is of Greek letters, and so on. Second, each set can be matched with every other set. Now imagine all the infinitely many sets that can be matched with these sets. Even though the sets will be made up of various elements, they will all share in the common attribute and that they are equivalent to the set of A, comma, B, comma, C. The common idea that is associated with all of these equivalent sets is the number 3. That is, the number 3 is the attribute common to all sets that match the set of A, comma, B, comma, C. Similarly, the whole number 2 is the common idea associated with all sets equivalent to the sets A, comma, B. All other non-zero whole numbers can be conceptualized in a similar manner. 0 is the idea or the number or imagines when asked how many elements are in the empty set. Okay. So kaya yung idea dito, ang pwede nating makita doon sa mga different element of the sets ay yung common associated, yung common idea that associated with all the sets which is equivalent to number 3. The symbol of n of A is used to represent the number of element in a finite set A. More precisely, example 1, the n of A is equals to m if A is equivalent to the set of 1, 2, 1, 2, and so on up to m, where m is a counting number. And number 2, the n of P, Greek letter P, is equals to 0. Thus, the n of A, B, C is equals to 3 since so the n of A, B, C is equals to 3 since the set of A, B, C is equivalent to the set of 1, 2, 3. And the n of the set of A, B, C up to Z is equals to 26. Ibig sabihin lang nito yung n of the set of English letter or English alphabet letter, which is equals to 26. Since the set of English alphabet letters is equivalent to the set of 1, 2, 3 up to 26 and so on for other finite sets. Children may get Ordering whole numbers. Children may get their first introduction to ordering whole numbers through the counting chant. Let's say 1, 2, 3, and so on. For example, 2 is less than 5 since 2 comes before 5 in the counting chant. A more meaningful way of comparing two whole numbers is to use one-to-one correspondence. We can say that 2 is less than 5 since any set with 2 elements matches a proper subset of any set with 5 elements. That we see in the figure 2.10. Yung nasa sets ng 2 elements can be properly matched doon sa sets ng 5 elements. So, kaya yung 2 ay tinatawag na proper subset ng 5. Therefore, 2 is less than 5. And that is the general set formulation of less than. Okay, so dito meron tayong dalawang way of ordering whole number. Yung isa ay counting chant and yung isa ay tinatawag nating one-to-one correspondence or yung tinatawag na sets, using sets. By definition, 2.8, ordering whole numbers. Let A is equals to the n of A and B is equals to the n of B. Then we say that A is less than B or B is greater than A if set A is equivalent to a proper subset of set B. The greater than and less than signs can be combined with equal sign to produce the following symbols. So A is less than or equal to B, or B is greater than or equal to A. A third common way of ordering whole numbers is through the use of the whole number line. Gaya nung nasa figure 2.11. Actually, the whole number line is a sequence of equally spaced marks where the numbers represented by the marks begin on the left with 0 and increasing by 1 each time we move 1 mark to the right. So itong nasa figure 2.11, tinatawag nating whole number line. So I start with 0, then meron lang 1 unit distance dun sa every line. Okay, so meron tayong 3 ways of ordering whole numbers. Yung isa ay by chanting chant or yung tinatawag natin na counting chant. Then yung isa naman one-to-one correspondence or by using sets. And the third ay yung tinatawag natin na whole number line. Okay, example 2.8. Determine the greater of the two numbers 3 and 8 in 3 different ways. So by counting chant, let's say 1, 2, 3, 4, 5, 6, 7, 8. Since 3 precedes 8, so 8 is greater than 3. By set method, since a set 3 elements can be matched with a proper subset of a set with 8 elements. So therefore, ito sa ating figure. So yung 3 ay match doon sa proper subset ng 8. So therefore, we say that 3 is less than 8 and 8 is greater than 3. And the third way, yung whole number line, since 3 is to the left of 8, yung 3 ay nasa left ng 8, di ba? On the number line, then 3 is less than 8 and 8 is greater than 3. Okay? Next, the definition of numeration systems. To make numbers more useful, systems of symbols or numerals have been developed to represent numbers. First, the tally numeration system. The tally numeration system is composed of single strokes, one for each object being counted. Kagaya na nasa figure 2.3. So, kung yung ginagamit nating symbol ay ito. So, single stroke lang. So, represent 1. Then, so kung dalawa na ay 2 strokes, represent as 2. Then, 3 figure, represent 3 strokes, and so on. The next six such tally numerals are the following. Okay? An advantage of this system is its simplicity. However, two disadvantages are the following. One, large numbers requires many individual symbols. And second, it is difficult to read the numerals for some numbers. For example, ayan, nakikita nyo sa left, sa right side. For example, what number is represented by these tally marks? Di ba kung nakaganyan yung nakikita natin, o, di ba? Medyo disadvantage, no? Parang ang hirap agad makita kung anong number itong ni-represent itong ating tally mark. The tally system was improved by the introduction of grouping. In this case, the fifth tally mark was placed across every 4 to make a group of 5. Thus, the last tally numeral can be written as follows. So, grouping makes it easier to recognize the number being represented. So, in this case, yung nasa right side natin, yung kanina, yung first figure natin, so pag ginamitan natin ng groupings, so mas madali na siyang ma-recognize. Kaya, at the end, alam mo na agad kung ano nire-represent nun, which is 37 tally marks. Kasi gumamit na tayo ng ano, di ba? Na-develop na using groupings. So, pagkadating na ng 5 mark, so, i-cross na lang siya dun sa 4. Kaya, ang representation niyan ay merong 5 strokes or 5 marks every group. Next, the Roman numeration system. The Roman numeration system, which developed between 500 BCE and 100 CE, also uses grouping, additivity, and many symbols. The basic Roman numerals are listed in the table 2.2. Roman numerals, meron tayong I, ang value niyan ay 1, V equal to 5, X 10, L 50, C 100, D 500, and M 1000. Roman numerals are made up of combinations of these basic numerals. For example, so yung CCLXXXI, which is equals to 281. And yung MCV III equals doon sa 1,108. Notice that the values of these Roman numerals are found by adding the values of the various basic numerals. For example, in MCV III means M for 1,000 plus C 100 plus V 5. Then yung 3I ay 111. So, ang equivalent nun ay 1,108. Thus, the Roman system is an additive system. Two new attributes that we may introduce by the Roman system were a additive principle and a multiplicative principle. Both of these principles allows the system to use fewer symbols to represent numbers. The Roman numeration system is a subtractive system since it permits simplifications using combination of basic Roman numerals. For example, IV. I to the left of B means 5 minus 1. So it will become 4 rather than using 4i. And another thing, yung ix, ibig sabihin 10 minus 1, 4 equal to 9. Instead of writing v, then 4i. And another is xl for 40, xc for 90, cd for 400, and cm for 900. Okay? One may wonder if IC is an acceptable way to write 91 or 99. Yung kayang pagsulat ng IC ay acceptable yon sa Roman numeration system. IC, so ibig sabihin magiging 99 yun. The question is if it is acceptable. To evaluate a complex Roman numeral, one looks to see whether any of these subtractive pairs are present. Groups them together mentally and then adds values from left to right. For example, in MCMXLIV, think M, then CM, then XL, then IB. So yung M natin is equivalent to 1,000. Then yung CM is 900. XL is 40. Then yung IB ay 4. So we have 1,000 plus 900 plus 40 plus 4, which is equivalent to 1,944. Okay? Notice that without the subtracting principle, 14 individual Roman numerals would be required to represent 1,944 instead of the 7 numerals used in MCMXLIV. Also, because of the subtractive principle, the Roman system is an positional system. Since the position of the numeral can affect the value of the number being represented. For example, in VI is 6, whereas IV is 4. So, kaya importante yung position dun sa Roman numeral. Kasi kung wala yung position, baka mag-equal yung VI and IB, which is not. For example, express the following Roman numerals in our numeration system. So, yung MCCXLIV sa Roman numerals, so sa atin naman, sa numeration system natin, that is 1,344. And yung MMCMXCIII sa Roman numerals, sa atin naman ay 2,993. And yung CCXLIX, that is 249. Think MCCXLIV or ito yung kumbaga separation ng position ng Roman numeral, di ba? Or, so kaya yung MCC, C ay magiging 1,300. Then yung XL ay 40 at yung IB ay 4. Kaya 1,344. Then yung MMCMXL, III, o MM is 2,000. Then yung CM ay 900 at yung XC ay 90 at yung 3i. Kaya 2,993. Then yung CC, that is 200. XL 40, IX 9. So we have 249. The Roman numeration system also utilized a horizontal bar above a numeral to represent 1,000 times the number. For example, yung B, ito, B tapos merong bar sa ibabaw ng B, meant 5 times 1,000 or 5,000. So yung XI, merong bar, meant 11,000 and so on. Thus, the Roman system was also called multiplicative system. And the next, the Hindu-Arabic numeration system. The Hindu-Arabic numeration system that was used today was developed about 800 CE. The following list features the basic numerals and various attributes of this system. First, yung tinatawag nating digits. So sa digits, let's start with 0, then comma 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8, comma 9. These 10 symbols or digits can use in combination to represent all possible numbers. Second, yung grouping by tens, yung tinatawag nating decimal system. Grouping into sets of 10 is a basic principle of this system. Probably because we have 10 digits on our two hands. The word digit literally means finger or toe. Then ones are replaced by 110. 10 tens are replaced by 100. 10 hundreds are replaced by 1,000 and so on. So yung sa figure 2.20 natin show how groupings is helpful when representing collection of objects. So the number of objects groupings together is called the base of the system. Thus, our Hindu-Arabic system is a base 10 system. Okay, recall that an element is listed only once in a set, although all the dots in the figure 2.25 look the same. They are assumed to be unique individually elements here and in all such subsequent figures. Okay, so meron tayong sets, then sa sets natin ay gumamit tayo ng dots. So by using by group, we have 3, 10s, and 4. The following two models are often used to represent multi-digit numbers. First, yung tinatawag natin bundles of sticks can be any kind of sticks banded together with rubber bands. Then, those sticks are bounded together with a rubber band to represent 10. Then 10 bundles of 10 are bounded together to represent 100 and so on. Gaya ng nasa ating figure 2.26. So kaya yung bundle of sticks ay so 1, 2, and 3. So meron na tayong 23. Okay, next, base 10 pieces, also called Dines blocks or Dines blocks, consists of individual cubes called units, longs made up of 10 units. So yung first lang unit, then ito tinatawag nating long. So yung long natin ay 10 units. Then yung flat 100 units na yung flat. And then yung block natin ay ano na 100, 1,000 na ito, no? Itong block. Inexpensive two-dimensional sets of base 10 pieces can be made using grid paper cutouts. Siyempre dahil kung dinis yung gagamitin natin, medyo kailangan mo pa ng no, three-dimensional objects. Pero pwede na lang gamitin yung grid paper. Okay, next is the place value, hence positional. Each of the various places in the numeral 6,523, for example, has its own value. Let's say yung 6 for the 1,000, 5 for the 100, 2 for 10, and 3 for 1. The 6 represents 6,000s, and the 5 represents 500s, the 2 represents 2 tens, and the 3 represents 3 ones. Due to the place value attribute, the Hindu-Arabic system. The following device is used to represent numbers written in the place value. A cheap abacus is a place of paper or cardboard containing lines that form columns on which chips or markers are used to represent unit values. Conceptually, this model is more abstract than the previous models because markers represent different values depending on the columns in which the marker appear. O kaya yung 20, so yung marker natin doon sa 2 tens. Then yung 200 naman, yung marker natin 2 doon sa hundreds naman, di ba? Then yung 2, doon lang mismo sa ones place value. So kapag sinulat na naman natin yung 326, so 3 dots doon sa 100, 2 dots doon sa tens, at 6 dots doon sa ones. Next, the additive and multiplicative. The value of a Hindu-Arabic numeral is found by multiplying each place value by its corresponding digits and then adding all the resulting products. Okay, so tingnan natin. So yung place value natin, thousands, hundreds, tens, and ones. So yung digits ay 6 for the thousands, 5 for the hundreds, 2 for the tens, and 3 for the ones. So in numeral value, we have 6 times 1,000 plus 5 times 100 plus 2 times tens plus 3 times ones. So in numeral, we have 6,523. So yun yung pinaka-detail ng ating ginagamit na Hindu-Arabic system. So kaya yung 6,523, ito yung detail ng kanyang numerals. So yung place value, digits, at yung numeral value. Okay, so kaya ang Hindu-Arabic system ay tinatawag din natin na meron din siyang tinatawag na additive system and multiplicative system. Expressing a numeral as the sum of its digits times their respective place value. It's called the numeral's expanded form or expanded notation. For example, the expanded form of 83,507 is, so yung 8, ang kanyang place value ay sa 10,000s plus yung 3 naman ay sa 1,000s plus 5 sa hundreds, then yung 0 sa tens at yung 7 sa ones. Kaya yung 83,507, kapag in-expanded form natin, we have 8,000 or 8 times 10,000 plus 3 times 1,000 plus 5 times 100 plus 0 times 10 plus 7 times 1. So tinatawag natin itong expanded form or expanded notation. Okay, so express the following numbers in expanded form. So yung letter A ay 437. So, ibig sabihin nun, kapag in-expand natin yung letter A, 437, so kaya siya ay magiging 4 times, so yung 4 ay nasa 100 place value, plus yung 3 naman ay sa tens, at yung 7 ay sa 1. Yan, okay? Kaya 437. At yung letter B, 3001. So sa expanded notation niya or expanded form, 3 times 1,000 plus 0 times 100, yung first zero. Then yung third zero, yung second zero sa 100, yung third zero ay sa 10. At yung last ay yung 1 by 1. Ayan. Okay? Okay, so yung 3001, ito yung kanyang expanded form. Okay, so naming Hindu-Arabic numerals. Associated with each Hindu-Arabic numeral is a word name. Some of the English names are as follow. Okay, so yung 0, yes. Then yung 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So kapag naman pagdating na ng dating na ng 21, so meron na tayong hyphen, 21, 87, and so on. And yung last natin, yung 23,100. So meron siyang hyphen yung 23. In numerals containing more number 3 digits, groups of 3 digits are usually set off by commas. For example, the number 123 quadrillion, 456 trillion, 789 billion, 987,654,321. Okay, so importante sa atin yan, no, yung gumagamit ng ng commas in every 3 digits. Okay? So in figure 2.29, graphically displays the 3 distinct ideas that children need to learn in order to understand the Hindu-Arabic's numeration system. So the number is the concept. Then yung numeral, yun yung ating symbol. At yung name or yung word, yun yung ginagamit nila sa chant or yung chanting. Okay? Non-decimal numeration systems. Our Hindu-Arabic system is based on grouping by 10. To understand our system better and to experience some of the difficulties children may have when learning our numeration system, it is instructive to study similar system, but with different place values. For example, suppose that a Hindu-Arabic-like system utilize one hand or yung tinatawag na 5 digits instead of 10 digits. Then grouping would be done in groups of 5. If sticks were used, gaya na nasa right side ng ating figure, if sticks were used, bundles would be made up of 5 each. For example, itong first figure natin, di ba? Ito yung first figure. So, group of sticks. Ngayon, pag binandal natin yan by by 5, ito na ang magiging result ngayon. So, nakabundle na siya by 5. Okay, here, 17 objects are represented by 3 bundles of 5, each with 2 left over. This can be expressed by the equation 17. 17 is equal to 32 base 5. Okay, so yung 70 natin, yung itong first figure, ito ay 17. So 17 base 10 ito. So siya ay base 10. Kaya, so, that is 17 base 10. Although kapag base 10 na ginagamit natin, automatic, 17 base 10 is also the same as 17. Hindi na natin sinusulat yung base na 10. Ngayon, dito naman sa baba, that is base 5. Kasi di ba na-group na natin by 5. So kaya siya ay base 5. Ibig sabihin, we have 3. Then yung 2 na left over, base 5. Then equal sila, di ba? Equal sila. Kasi itong base 5 natin, dito rin natin kinuha sa 17 base 10. So yung 17 base 10 is equal to 3 to base 5. So hindi natin binabasa ito na 32. Ang basa natin dito ay 3 to base 5. Okay, yung nasa base number natin, yun yung kanyang subscript. So, yung base 10, pwede rin siyang number na rin gamitin. Ganyan. So, 17 base 10. Pwedeng yung word mismo. Or, pwedeng wala na mismo yung base number or base subscript. Automatic na siya 17. Pero dun sa sa 32 base 5, pwedeng by word or pwedeng by symbol na rin. So 32 or 32 rather 32 base 5. Yan. Okay? So yung pagsulat ng subscript ay medyo maliit na. Okay, so ito yung isa pa nating yung paggamit naman ng Dines block. Okay. So base 5, so we have 3 base 5, then base 5 block representation. So meron tayong 3 blocks. So sa base 10 naman, that is equivalent to 3. 1 4 base 5. So we have 1 long and 4 chip, no? Or yung 4 block. Ay, hindi. 1 long and 4 units. O unit to, you know. So kaya 1 times 5 plus 4, we have 9. Then yung 1, 3, 2 base 5, meron tayong 1 flat, 3 longs, and 2 units. So kaya 1 times 25. Kasi yung magiging flat natin sa base 5, 25 lang yan. Plus 3, yung long natin ay 5. 3 times 5 at yung 2 units. So we have 42. At sa 1004 base 5, meron tayong 1 block at 4 units. At yung block natin sa base 5, that is equivalent to 1,000 or 125. So we have 1 times 125 plus 4 or 129. So it means kapag nilagay natin sa symbol, yung 3 base 5 ay the same yon sa 3. At yung 14 or 1/4 rather, 1/4 base 5, equivalent yon sa base 10, ang equivalent nun ay 9. Then yung 132 base 5, ang equivalent nun sa base 10, 42. Then yung 1004 base 5, equivalent nun sa base 10 ay 129. Okay? Counting using base 5 names differs from counting in base 10. The first 10 base 5 numerals appear in the figure 2.32. So, kaya yung 1 base 5, meron tayong 1 unit. 2 base 5, 2. 3 base 5, 3 units. 4 base 5, 4 units. Pero pagdating na ng 10 base 5, dun pa lang ang 1 long. At yung 1 base 5 ay 1 long and 1 unit. 1 base 5, 1 long and 2 units. So pagdating naman ng 20 base 5, meron na tayong 2 longs. Okay? So kaya yung pag sinulat natin yung 24 base 5, so meron siyang particular na figure, yung 34 base 5, 44 base 5, and 444 base 5. So magkakaiba yun ngayon ng kanyang long, pwedeng meron na ring block, pwedeng may long, may block, and may unit. So yung figure 2.33 show how to find the number after 2, 4 base 5 using multi-base or multi-base pieces. Okay, kaya yung 2, 4 base 5, meron tayong 2 longs and 4 units. So that is equal to 2, 4, 2, 4 base 5 plus 1 base 5. So exchange this for a long. Kasi 'di ba itong 4, pag dinagdagan pa natin ng 1 or itong unit, 'di ba meron na tayong 4 unit. Pag dinagdagan pa natin ng isa, mabubuo na siya as 1 long. So therefore, hindi na siya mapapabilang as unit, kundi mapapabilang na siya as long. Kaya kung meron na tayong sa 2, 4, ay meron na tayong 2 long. Then pag dinagdagan pa natin ng 1 base 5, magiging 3, 0 base 5 na yan. Kasi magiging 3 long na yan. Converting numerals from base 5 to base 10 can be done using multi-base pieces or place values and expanded notation. Dalawa yung pwedeng express natin kapag converting. Bawa, yung base 5 to base 10. Let's say, express the 1, 2, 3 base 5 in base 10. Then, tingnan natin. So, using base 5 pieces, so yung 1, 2, 3 base 5, that is equivalent with 1 block or 1 flat, then 2 longs and 3 units. So, we have sa base 10, yung 1 flat ay 25 at yung 3 long or yung 2 long ay 2 times 5 at yung 3 units. So, kaya yung sa base 10, yung 1, 2, 3 base 5 ay magiging 25 plus 10 plus 3, which is 38. Thus, the 1, 2, 3 base 5 is equivalent to 38. Okay, sa ano naman, using place value and expanded notation. So, yung place value ng 1, 2, 3 base 5. So, yung 1 ay naka-place value sa 25. At yung 2 naka-place value sa 5 at yung 3 sa ones. So we have, kumbaga parang ito yung ano ito yung ones, tens, hundreds sa base 10, di ba? Ones, tens, hundred. Kaya kapag kinuha natin expanded notation, 1 times 25 plus 2 times 5 plus 3 times 1 equals to 38. Okay, next. Convert from base 10 to base 5. Pabalik naman. Kanina, base 5 to base 10. Ngayon naman, base 10 to base 5. Let's say meron tayong dalawa. A, 97 at yung B ay 341. Using base 5 pieces. Okay, so yung 97, so ang base 5 pieces natin, so base 5 place value, ito. 25, ones, 5, 25. Expanding. So yung 97 is equals to blank, blank, blank. So dito sa letter B, yung given natin ay 341 base 10, then convert to base 5. Okay, first find the highest power of 5 that will divide into 341. So ang pwede ay yung 125. So if we divide 341 to 125, we have 2. So meaning, meron na tayong 2 times 125 plus, then yung remainder ay 91. At yung 91, pag tingnan natin sa greatest power of 5, so pwede siya sa 25. Okay, so sa 25 ay, ang 91 ay merong 3. So 3 times 25, 91 divided by 25, we have 3, then remainder ay 16. At yung 16 ay pwede na siya sa 5. Okay, so ang 16 ay meron tayong 16 divides 5, meron tayong 3. So plus 3 times 5. Then yung remainder ay 1. So yun na yung para sa unit. So therefore, ang 341 sa base 10 ay meron tayong 2, 3, 3, 1 base 5. Okay? When expressing place values in various bases, exponents can provide a convenient shorthand notation. So the symbol a raised to m represents the product of m factors of a. Thus, 5 cube is equal to 5 times 5 times 5. 7 square is 7 times 7. 3 to the 4th is 3 times 3 times 3 times 3, and so on. Using this exponential notation, the first several place values of base 5 in reverse order are 1, 5, 5 squared, 5 cubed, 5 to the 4th. Okay? Example, express the following numbers in base 10. So, yung 1, 1, 0, 1, 1 sa base 2. At yung 1, 2, 3, 4 base 8. At yung 1E T base 12 naman. Note, base 12 has 12 basic numerals 0 through 9. And then for T for 10 and E for 11. Okay, so for letter A, 11011 base 2, that is equivalent to 27. Letter B, 1234 base 8, and that is equivalent to 668. For letter C, 1ET base 12, that's equivalent to 286. And for the last example, convert from base 10 to given base. Letter A, 53 to base 2. Letter B, 1982 to base 12. So letter A, that is 110101 base 2. And for letter B, 1982 is equivalent to 1192 base 12.